I'm here mainly to present research that I've been conducting over the past few years at MIT in Cambridge, Massachusetts, with regard to interactive interfaces to show data and analytics to stakeholders. The image I want to conjure for you at my office is actually one of a little bit of playfulness and chaos. This is actually outside of my door, where we're kind of swimming in Lego. And it's a very unique place where we can actually do serious research, but also have serious play as a part of that research track. One reason that this environment can exist is because of the environment provided at the MIT Media Lab. It's actually a recent addition to the MIT campus, where many faculty from different areas that don't quite fit into traditional research areas can come and find a home. We call all of these different research groups, each with their own faculty, anti-disciplinary research groups. They're not interdisciplinary necessarily, but really everyone is expected to have to learn lots of new skills on the fly and pull in people from different fields to do any number of research we're doing. If you can do your research in just a normal physics department or computer science department, and you don't need a fashion designer or something, you probably won't find a great fit here. One of the reasons this is capable is because the lab is uniquely able to work with industrial collaborators as funders and sponsors and supporters of the research. So any number, more than most of the campus, industry works with us to make these research discoveries. You probably noticed many of these companies are actually Japanese companies to this day. So Japan is a very important collaborator for us at MIT. And of course, one of the companies is Lego, in case you were wondering as well. They don't actually give us money, but they give us all the Lego we need. I'm just kidding. But just an example of some research that comes out of the lab, not me, but my colleagues, Professor Hugh Herr, he looks at bionic limbs, but not just in the context of the medical industry, but also in integrating robotics, engineering, and fashion. And uniquely, this research is capable there. If any of you have played a game called Guitar Hero, it was very popular in the United States, but this game concept and the controller was developed at the lab and turned into a game company. The laptop, called the laptop for children, the $100 laptop, or ichiman yen, was designed to be durable and robust, and so that you could send it to developing countries, and it had all open source software so that children in developing countries can learn how to use computation from a young age. My colleagues on the City Home project are taking the challenge of apartments getting smaller and smaller, especially in places like Tokyo, and in that small footprint, developing robotic technologies that allow you to get more out of the space. So how can the same space become a kitchen, a bedroom, a living room? How can it become larger and smaller to accommodate different activities? And this, too, is becoming spun out into a company called Ori. We even study automobiles and concepts for shared vehicles that will operate in the future in an autonomous way that will deliver passengers and goods and also be electric and require new urban infrastructure for them. And we're not just into building concepts, we're into actually building prototypes, so physical manifestations of our ideas that give a proof of concept of what's possible. So this is the city car being built in Spain and being road tested. So with that background and my colleagues' research in mind, maybe it makes little sense why research like the interactive visualization tools I'm developing can exist. The primary role I have now is maintaining what we call the Interactive Visualization Laboratory. And the Interactive Visualization Laboratory is a place where we encourage novel interfaces for collaborative decision-making. There we actually facilitate education, so teaching students these tools so that they can use them in their studies, other departments, and maybe when they're out and working in the world. We also facilitate research. So research scientists like me who engage with corporations to build new models and new devices and run experiments on teams and teams of people. I should mention simultaneously right now my colleague Ike-san is giving a presentation on Global Team Lab in their work, and they're experts in studying the interactions of teams, and they might actually be utilizing this space. And then finally, outreach. It's very important for us to not just do our work in a closed room where nobody can see it. We're very public about the research we're doing, and we want people to know what we're doing so we can get feedback, make it better, but also make sure that we're staying relevant. So the status quo paradigm for working with data and building models is data to insight. We're probably very familiar with this kind of goal from the digital traces in the world and our mission to turn that data into useful information that we can use to make actions. But in the interactive visualization lab, we try to break this down a little bit more into its component parts. So for instance, in between data and insight, you actually have a lot of work with regard to doing analytics and actually the user interface design so that you can view and understand those analytics and actually gain enough awareness so that you can actually make insight. And we also need to acknowledge that most people in this conference are talking about data and how it's changing. And in the broadest sense, data is becoming from more and more disparate sources, both from instrumentation, but also public and private sources. So really, this societal component is important to acknowledge as part of the loop as well, because as researchers, traditional researchers, even like in the lab, we hope that the data kind of falls from the sky magically into our laps. And once you have the data, you can finally get to work. But it actually is a process to get the data in a meaningful way, too. And actually, data insights isn't linear, it's a loop. Because once you actually get the insight, make actions on them, and create an impact on society, that feeds right back into your system that you would hope is then measurable, and then will inform your next round of analytics and decision making. And for the more technical people among us, we know that the step from data to analytics actually is an intensive process of creating models and actually filtering data and smartly creating an abstraction of the universe so that we can actually make a meaningful jump from data analytics. This whole ecosystem we're calling a socio-technical system. The mix of social and technical components that make up how society works. And the IVL is facilitating tools that allow the socio-technical system to work better. So the principal technology that I'll be talking about today that the IVL uses is called a tactile matrix. It's just one example of an interactive visualization tool that we use a lot because it makes data and models and analytics more accessible to stakeholders. And when I say stakeholders, I mean people who are affected by decisions and choices about either industry or society that are not necessarily the experts, but they are people who should have a say in how the decisions affect them and what is ultimately made. So the tactile matrix actually started very low tech. It was born in these workshops where we actually had people from different backgrounds talking about city planning who weren't actually city planners, but the Lego bricks provided a way for them to talk to each other. And these bricks, we assign meaning to them, both quantitative and qualitative. For instance, a brick could represent a certain amount of people or an amount of area or a type of land use. And the first breakthrough where we knew we were onto something was this result right here. This is 4 groups who designed 4 different city scenarios using the same template, the same kit, and the same mission. They were told to build a sustainable square kilometer in China using the same kit of Lego. So each of these scenarios has the same amount of bricks and on average looks the same, but we were excited because there was so much diversity in what the human component could offer as far as creativity. The downside was that once they had these models, it was very hard to digitize them and do very further analysis because we didn't know how one city performed next to the other than a qualitative understanding. So this is why I invented the Tactile Matrix. It is a platform of Lego blocks that is updating a digital model at the same time in parallel. And the way this works is through computer vision and projection mapping so that the white Legos are actually encoded with data that is updated in real time as a user intervenes in the system. The main reason for this is so that you can preserve that ability to build a very low technology, just Lego brick city on the side, and then bring it in for scanning and editing. So you don't have to know computer programming or any fancy software to make your own digital city model. So hardware-wise, this, and again, this is why I think this is only capable at a place like the Media Lab, because I had to learn projection mapping, computer vision, 3D game engine design, and actually have access to a workshop to make the hardware for the tables that are necessary for this. And also a mature understanding of space and how to arrange this technology in a space so that it can be effective. But more important than the nuts and bolts and the hardware are the analytics. So the project now has evolved to a point where we don't focus so much on the table anymore, but it's for any given project, the analytics and the models and simulation scenarios that go into any tabletop design, because it's just an interface, and without good models, they're not particularly useful. So one of the early models we made was to simulate walkability in a city. So in this case, you're placing an office building, and if the office building is in an area without housing, it scores poorly. But if you place that office building near housing, within walking distance, you're actually improving an urban planning score for walkability so that people can commute to and from work. We also quickly adapted it for the city of Toronto. They wanted to have a tool that let them gauge the effect of residential and commercial density on traffic in their downtown areas. So here in green, you see a road, scoring red to green being the traffic, green is low traffic, and then in blue, you have the office buildings, and red, you have residential. So as a user places commercial buildings up front, and only commercial, they need lots of parking, and they're generating lots of traffic in this urban area. But soon the user figures out that if they place residential areas co-located with the housing, they're actually creating the probability that more trips will be walked, and also creating less risk for traffic congestion in this area. So the main point here was the city wanted to show, so this is a tool for learning at this point, the city wanted to show that you can increase density in a city while potentially reducing traffic, which is not necessarily an intuitive thing for most planners to teach. Another work we did was to build these community engagement tools. So the tool is adapted to allow users to place bus stations in a street and visualize how it might affect their neighborhood. And the interesting thing about this scenario is we actually had to build different scales of the tool, one at a street scale and one at a neighborhood scale. We've even developed these more for an architectural scale, so there's a whole city block, and each building you can reprogram the land use within that building block and then place it on a table of a larger development. We took this idea full scale to our own backyard. We decided to rebuild our entire campus at MIT out of Lego bricks. And this is what our researchers do late at night, build our Lego models for our research. And what we ended up with is this giant Lego model of Kendall Square in Cambridge. And the Media Lab is actually in the lower left corner right there. And in this model, there's actually an empty parking lot that over the next 10 years is reserved for development of high-density buildings. And we wanted to create a place where you can take a bank of buildings, place them in our model, and see how those buildings would impact the surrounding neighborhood. So we designed the model to give you feedback on, say, whether you're following the law, if the building broke zoning code, and the type of traffic you would generate. And we held multiple workshops where people would come and design their own city over the course of 15, 30 minutes. And we took data on their interactions. We actually saw how different groups had different dynamics. And overall, their satisfaction with the design process and their feelings about their engagement with the design before and after doing this exercise. And one thing we noticed very early on is once you have a platform, you can put any number of data in it. So we've experimented with lots of different data sources. Multi-mobility was one that came on early on as one people were interested in. And even just basic satellite imagery to get a sense of realism in the models. But we also looked at solar radiation, how much sun you were getting in different parts of the city. Wind flow analysis. Boston is very windy in the winter, and actually it's very important how you place the buildings. Actually, in Roppongi Hills, even if you walked into the building, it's very windy, and it might be something you could see in a model like this. We're even modeling using data from a small company called Context Labs, the industry's location and the amount of money in each industry. And very bright in the middle here, yellow, is Tim Rose CIC. So that's the building where all the startups in Cambridge are, and it's definitely a hot spot of activity in our backyard. And this is Twitter. A lot of folks probably know that you can tap directly into Twitter's fire hose of data and look at it in real time. And in that case, I'm sending a tweet to Twitter, and the models are programmed to detect tweets and their location in real time, and the Media Lab lit up in red as soon as I sent that tweet. So that's a bit of an overview of the research, the fun we have with these models. But like I said, a big part of the interactive visualization lab is outreach, doing our experiments in the context of real-world problems so that we can have better impact on the world. And one of my first collaborations was with Saudi Arabia, the development authority in Riyadh. We designed a prototype that took a square kilometer area and allowed us to make a new city design in this area. And we built a few models of impact analysis for, say, walkability, daylighting, and energy, both at a micro scale, but an aggregate scale. And the development authority was kind enough, again, to let us take the device to Saudi Arabia. And we had multiple workshops where Saudi planners would use the model to figure out a city design scenario, and they could export those results at the end of their session. And they had people at both high levels and low levels mixed together, and they let us, say, put a table of only experts at the table or a table of only low-level planners at the table, and we could see the types of outcomes we were getting. So they're very kind about letting us take data on step by step. And again, this is, I think, an important step in this type of research, is not just to create the interfaces, but to more actively measure how they're being used so we can understand if they're being effective or not. So I'm not claiming yet that this is the best tool in the world for every situation, but we're starting to understand how people in learning are affected through the use of these tools. Another collaboration is with China. So we find not just governments, but companies are interested in figuring out how these tools can be applied. A company called iSoft Stone is an IT consulting firm. They are doing a number of smart city projects in collaboration with the Chinese government. So we adapted the platform here to look at Pengzhou in China, which is near Beijing. And they're starting to roll this out as a consulting service model. One of the more unique problems we dealt with is this small country of Andorra who approach us. I don't know who's heard of Andorra, but it is a country that has the population of a small city, and it's between France and Spain. And the goal here is their primary concern is tourism, because they're so small. Their economy is 99% tourism activity. In fact, their population at any given time is mostly tourists, not the actual native population. So we're developing a model concept that would specifically help them infer tourist activity and the impact of potential interventions with this system. So we're just getting started on this now, but some preliminary data that we can get a hold of, because it's a small country, is telecom data directly from the country's telecom cell phone service provider. So in this visualization, you're actually seeing French tourists in blue and Spanish tourists in orange that we can sense with the metadata, and seeing over time how activity changes. So right now in orange is the Spanish coming out of the Cirque du Soleil event on that particular hour. And this is an interesting observation because when we first saw this, we didn't know what it was. We're like, why are all these Spanish tourists here? And we had to ask, like, what event is going on? And it was the Cirque du Soleil. It also means that, though, everyone in that auditorium has their phone on. So if you have your phone on now, we can probably see that in the data, at least in Andorra. Finally, one of my favorite collaborations was with the city of Hamburg in Germany. This was a university collaboration, and it was a very friendly cooperation where they have a school for planning at the Hafen City University. And I flew in and over the course of a week helped them build their own platform. So I went over there with a suitcase and some Lego, and using their workshop, their tools, we built one from scratch. And then we even made a lot of changes based on the way the students there like to work. For instance, we used hand-built models in combination with the Legos so that we could build a model of a neighborhood near their university. So over the course of a week, we built this and we got it working and set up. But then we spent a week doing tutorials, teaching the students how to make changes and how to hack the system so that they could actually use it themselves. So because after a week I was going to leave, and it's not enough just to give people technology, they have to understand and find value in it to use it. So we got it programmed with the basic neighborhood, we showed it at a tech conference, and then I said goodbye. Before I left, though, they were already starting to hack it. One of the students really liked hand drawings, like hand sketches. So they actually found a way to bring their hand sketches into the model and show them using the projector. So after I left, and only about a month or two afterward, the Syrian refugee crisis happened. And this city in Hamburg had to accept 80,000 refugees in less than a year. And the mayor, who is funding this research, actually went to the university and said, I know you're doing this city planning research. How can we use this to help us allocate refugees in a way that's politically savvy and makes the community feel like it's being involved? And with a little help, but for the most part, the German students reprogrammed the table themselves to respond to this because they needed it within a month or two to start doing workshops. So the German students actually started coding as soon as the mayor came, and they turned it into an interface for helping to allocate refugees in the city of Hamburg. And they had a number of workshops, and you can actually go to the website where they are, findingplaces.org, and see the ongoing work that they're doing. So I'm very proud of them for taking the work where it has. Also, briefly to talk about collaboration with Walmart. Sometimes a company will come with a very direct need and say, well, we want to actually get into the business of delivering groceries to people's homes. This is something they don't usually do. They have lots of stores that people come to, but in this case, they wanted to take their understanding of deliveries and the cost for doing last mile logistics and integrate them into a new platform. And they're even thinking ahead to a future where these deliveries are made by small autonomous vehicles, perhaps. So first we built a model so we could take the population of a potential area of demand like San Francisco. So this is the population. And then if you place a distribution center, it'll automatically calculate the service area for that distribution center. And then if you place a second distribution center, it'll actually recalculate the ideal distribution that takes into account both stores. And finally, a third, and so on. This cost algorithm is such that it's dependent on not just distance, but population, which is why you see all these interesting patterns. so we took that model and put it into a table form so that they could actually engage people within their company to get buy-in for this radical concept they had for dynamic service area allocation. Finally, one of the more recent collaborations with the city of Singapore, not-for-profit called the Center for Livable Cities. And we wrote an algorithm that, in particular, took the amenities of piece types like hospitals and schools, and if you place them on the table, it'll actually connect them to public transit like bus stops and trains and homes, and calculate the pedestrian pathways that you would create through the use of these amenities. So here's an example where you have, in blue, that office building, and if you place it close enough to the bus station, it'll make a connection and actually show how the trips to that bus stop might be done, or to the train station. So that's kind of where the research is going now. The Viz Lab is always interested in having exciting new problems, collaborators, exciting new data sets. So hopefully that's not just that's only the beginning of what we're doing here. So quickly, I mocked up an idea about using a similar platform in Tokyo. As you know, the Olympics is thinking of how to join Meiji Jingu Gaien to Toranamon and all the way to the Olympic Village via this grand transit corridor, underground buses, things like that. And the Toranamon area itself is of particular interest because of the idea to develop this into a grand boulevard with walkable streets and lots of shops and cafes. So it'd be an interesting idea, I think, to model that area. So this was all done for fun. And imagine how that could have a bunch of models associated with it that would help people discuss how the vision for that neighborhood in the future. Let's see. Yeah, so without further ado, oh, sorry. All right. All right. Well, I'm going to wrap up my presentation there. I think I have a little bit of time for questions if anybody's interested in having a go. But thank you for your time. Arigatou gozaimashita.
Thank you for the presentation. Just on a technical perspective, how long did it take you from the start of a conceptual idea until you had a working prototype with all the projection, and of course all the learning process where you had to learn many different things?
It's a good question. It's what's one way to describe it? Well, in the beginning, before there was even an interface of sorts, and that's in particular the Tactile Matrix, the Lego interface, there was literally nothing. And we had a collaborator kind enough, in that particular instance, Saudi Arabia, who was willing to let us build something new. So in the case where there was nothing, we actually developed that interface over the course of maybe 6 to 8 months. And had a proof of concept that the interaction worked. And then after that was working, then we went all in on the content development. So we actually had to build our own models from scratch as well. And I'd say to build a good model, for us, we took about a month or two of engagement with their relevant experts to get enough input that we understood their universe correctly and had all the correct data sources we needed. And then to implement the model, though, is another month or two. Integration, a few weeks. And at that, because we're researchers, we have the luxury of not putting too much work into beta testing and debugging. And once things are kind of working, we're really interested in doing experiments right away on the users. So once they get to a working point, we can actually start doing user testing. So all that, typically, I think a year is reasonable. Now one of the fastest projects I ever did, which was great, was with like organizations like Singapore or Walmart. because the tools were so well developed at that point, we could just dive, and they were willing to reuse them. We could dive right into the development of the models, get right into the data. And then the interface is becoming more and more an option of how to display or interact with your data and models. It's not necessarily something you have to reinvent every time. So that was, I would say, 3 to 4 months at that point. Thanks. All right, I'm getting the stop sign. Thanks for your time. I'll be around today and tomorrow. If there's one last question, then.
ありがとうございました。1点質問があるんですけど、分析の時は、どのようなやり方で分析をしていくんですか。もしくは例えば専門家を呼んでディスカッションするであったりとか、どういう点を見てなんですかね、インサイトを発見していくのか、その辺に興味がありましてお答えいただけたらと思います。
Okay. I might ask for a translation just so I'm sure I got it.
So basically, how do you do your analysis? Like, what approach do you take?
Okay. So one thing about these projects is there's never a consistent approach because they can be so different. But just to give you an example, I think it's really important to work with experts in their fields who are maybe not comfortable using tools or building interfaces like this, but who have a very solid understanding of the mathematics and theory behind their work. And then only then you can start to think of a way to integrate or implement their theory into an interface. Of particular data sets, I really like voxel-based data sets. You've probably noticed, so clouds of points and kind of massively correlating and computing those clouds of points. But really, you just have to be flexible and just kind of live with that as a researcher. All right. Thank you. I'll be around today and tomorrow, so I'm looking forward to meeting a lot of you.